go to the, all right, today is measurement. And measurement is a relatively easy topic because it is the first chapter in Form 4. Form 4 is year 10, which is grade, I think it's grade 10. Right. Form 4 is what we call in Malaysia. Now, so as usual, we're going to set up start time. It's 6:10 a.m. We are 10 minutes late because we took 10 minutes to revise the gravitational force. You see, it's even less than 10 minutes. Right, less than 10 minutes, we're able to revise the entire gravitational force. By now, your level of understanding should increase a little bit. If you were at, let's say, 10 minutes ago, right, by just doing this revision with me quickly, in this less than 10 minutes, you should go from 5 to somewhere higher, right? If you're at 9, then obviously you're still at 9, right? Now, so first step, first step is to remember the drawers. What are the drawers? We have 5 drawers. We have measurements, we have base quantities, we have derived quantities, we have scalar and versus vector quantities, and we have graph. So the name itself called measurement is to teach you today, or is to explain to you how do we define measurements and what type of measurement we have. So in terms of quantities, right? So that's why you see so many quantities, the terms over here in the drawers. So how do we remember these 5 drawers? Me, the bass drummer, meet Scarlett and Victor riding giraffe. So you can imagine that, you can picture that as an animated video in your brain right now, how this story will turn out. You, who is a bass drummer, because you are a drummer, you know drum, and there's a different type of drums. This is a bass drum. And you meet 2 of your friends, which are Scarlett and Victor, who is riding giraffe, right? So me, obviously, is reflecting the first drawer name, which is measurement. Then base quantities, measure, this is a second drawer, base. Drummer, D, I use D to help you to remember the derived quantity, right? Scarlett and Victor, scalar and versus vector quantities. So there are 2 types of quantities that you need to learn later. And graph is like giraffe. So let's watch this video. Okay, this is also the same animated video that we try to. It's almost 1 minute. Wait, I think I need to stop sharing and share you with the sound. Okay. Right. So remember that me and the Scarlett and the Victor story. Okay, let's watch this for a few seconds.
Form 4, Chapter 1, Measurements. Me, the bass drummer. Meet Scarlett and Victor riding giraffe. Draw 1.
Right. So that is the very short story for you to remember these 5 drawers name. Now, let's go to keynotes, step 2. Okay, on this side, step 2. I hope you are able to watch the video and also there's sound, right? If not, let me know. Okay, so let's go to step 2, keynotes. Now, just like I say, like I always start with at the understanding of level 1 to level 10. 10 is the highest, 1 is the lowest. Your understanding after reading these keynotes should be between 1 to 2. Right, 1 to 2 is still a very low level. So if you don't understand when you read this is fine. So let's take, let me pull out my clock first. Right, let's take 2 minutes to read from drawer 1 until drawer 5, until conclusion. Start now. 45 seconds. You should be in drawer 3 or 4. Ten seconds. If you have read it, you can reread it if you want. Right, time's up. So let us spend a little bit of time to break down the drawers. Right. The name of the drawers, I think you should have some idea on what is the name of the drawers. Right, based on the main story. So there are 5 drawers. So how do you read these keynotes? There are 5 drawers. Each drawer is having their own key concept. So for example, for drawer number 1, you have 3 key concept over here. Then drawer number 2, also you have these 3. Drawer number 3, you have about 2 here. Number 4, you have 3. Number 5, you have also 3. So generally, it's about 3 key points that you need to understand for each of the drawer, right? So when you read these 3 points, if you do not understand fully, this is fine, because it is a very concise version of what you're going to learn in the following steps: step 3, step 4, and step 5, right? So you just need to have a feeling that what are the key concepts that you will be learning over the next 1 to 2 hours, right? So you know that it is going to be a lot about the quantities, the units, right? Even they have name for the quantities, like scalar versus vectors. And then they have different type of quantities. They have this category. They have this base quantity, and they have derived quantity. The name itself is telling you this is the first level, base, foundations. Then they build, it's like a building block. They build the derived quantity from the base, right? From the base, right? Then this is how you use the quantity. Then this is the scalar quantity, of course, scalar quantity and vector quantities. And we're going to learn that later. And sounds like they are having this magnitude and directions, right? The difference between scalar and vector. They're having these 2 important key differentiations. Then you have graph. How do you analyze graph after learning these quantities, right? Now, so this chapter is relatively easy compared to the previous few chapters, like wave, like gravitations, right? So even when I explain this, it sounds easy. I hope it is. Okay, I hope it is. So there is no complicated and weird formula like the gravitations, right? So, but your understanding level now at number 2 out of 10, number 2, right? Number 2 is a very low level, and which is fine. Now let's move to step 3. Step 3 from drawer 1 until surface. If you realize, it is also divided into 3 important concepts: 1, 2, and 3. On your right is also 1, 2, and 3. The difference here is this is an extent on the right, on the left, on the left, the step 3 is an extended version of the step 2. So obviously, if step 2, you're able to have your understanding at level 2, after reading step 3, your understanding on drawer 1 should level up a bit, right? From 2 to level 3, right? So this is the expectation that you need to be expecting before you start reading drawer number 1, right? You need to have an end goal. Why you are doing this? Your end goal is to help you from going from 2 to 3, right? So let's take 2 minutes to level up your drawer number 1 from 2 to 3 by reading this from drawer 1 until surface. Let's do it in 2 minutes. Let's start now. Okay, 15 seconds. All right, time's up. This is drawer number 1. Right, let's move to drawer number 2 with the same idea to increase your understanding level from 2 to 3. 3 is already enough, right? If you do not understand fully, you should be setting your expectation to only to level 3 out of 10. So on the right, you have step 2 for drawer 2. On the left, you have step 3 for drawer 2. Right? It's the same 3 points over here, 3 key concepts, but it's an extended version. So let's do also 2 minutes. I think 2 minutes is a bit long, but it's fine. We do slowly, then we will go faster. For start now, 2 minutes. One more minute. Twenty seconds. All right, I think we'll stop here. Right. When you read this, I think for most of the students, especially for Asian student like Xingling, you have the tendency to memorize this once, or memorize this now. Right? If you have the tendency and you do not have able to memorize this, and that is fine. Later, I will have another story for you to remember this easily. So there are 7 base quantities. And what are the 7 base quantities? If you do not remember this and you have this tendency to memorize it, and obviously you would not able to memorize it in 2 minutes, don't worry. We have another way to help you to remember it easily. Right. For now, you just need to know there are 7 base quantities, and you need to know maybe some of these very common base quantity like time, length, mass. Right. That's it. Okay. And the derived quantities, don't worry, you don't need to memorize this. All right. Okay. So we will do 1 minute for drawer 3 because drawer 3 is very short. 1 minute. $25 seconds. $10 seconds. All right. So drawer 3 is derived quantities. So remember, we have 3 drawers we have already gone through. Drawer number 1 is the measurement. Drawer number 2 is base quantity. Now drawer number 3 is derived quantity. Me, the bass drummer. Measurement, the bass, and drummer. Drummer, which is derived. Next is I meet who? I meet these 2 guys who is riding on the giraffe, and her name is Scarlett and Victor. So scalar quantity, vector quantity, and giraffe is graph. Right? So same process. We'll do 1 minute for drawer number 4. Let's learn what is scalar and vector. $30 seconds. $10 seconds. All right. Scalar vector. Next is graph. Okay, it's a bit long here from drawer 5 until phenomena. Let's do 2 minutes. Let's start now. One more minute. You should be in point 2 now. 20 seconds. Okay, right. Let me emphasize this. I'm not your physics teacher. I'm guiding you how to learn using this study method, which works for me, and I hope it works for you. Right. As you read, I'm also reading. This might be your first time reading the notes. It is my at least second or third time because I learned this maybe a few days before you. Right. So that's how I get the notes. I created the notes. And I think it's proven by just following this step 1 until step 10 in less than 2 hours, you are able to increase your knowledge from 1 to near to 9 or 10, right? So now let's go to FAQ. We have a few FAQ over here. After FAQ, we'll give a short break, like we always do every week. So this question number 1 is drawer 1, right? So let me bring down this drawer 1 as a reference over here. So whenever you read these questions, ask yourself whether it is related to 1, 2, 3, or the whole thing, or 1 or 2, some of the points over here. Then read the answer. So this, you should be expecting, what is the expectation? After reading this, your understanding level from 2 or from 3 to 4. Right, from 3 to 4. There are 2 questions. So after reading these 2 questions, you should increase from 3 to 4. I'll give 2 minutes for these 2 questions because I think it's very easy. Right. I hope it's also easy for you. From drawer 1 until quantities, 2 minutes. Twenty seconds, you should be in question 2 already. All right, time's up. Right, I hope by now your understanding level of drawer 1 is at level 4 already. Right, level 4 is still at a low level. Right, out of 10 questions, I'm expecting, or you should be expecting yourself to get only 4 correct answer, which is low. Right. So if you, at this point, if you still do not fully understand what is measurement, it is fine. It is fine. Right. You're going to understand it more when we go into step 5 and 6 and so on. Right. Let's go to drawer 2. Okay, let's go to drawer 2. We also do 2 minutes for question 3 and question 4. I'm going to slow down a bit because it's just 2 rows that is hidden over here. Let's start now. Question 3. Okay, I'll scroll down a bit. Yep, that's it. One more minute. You should be in question 4 by now. Thirty seconds. Ten seconds. All right. Now we have done drawer 2. So your drawer 2 level should increase to 4. Right? Drawer 3, now we are trying to increase to 4 as well. So there are also two questions. Right? Let's do the same drill for 2 minutes. Let's start now. From drawer 3 until the last one, vector. Okay, 1 minute. You should be in question 6 now. Twenty seconds. All right, 10 seconds. Okay, time's up. Okay, before we move on, just to see a show of hand if you are still with me. Singling and Aiden. Yep, Aiden is here. Singling. Okay, good. Right, so we will do the same drill for scalar and vector quantities. Scalar and vector quantities. 2 minutes. Start now to increase from 3 to 4 for drawer 4. One more minute. You should be in question 8 now. You can read it again if you finish reading the whole thing. All right, 10 more seconds. All right. So this is if you remember the main story, this is Scarlett and Victor, who is riding on a giraffe. Right, so giraffe is the drawer 5. Let's do 2 minutes, same drill. One more minute. You should be in question 10 now. Twenty seconds. All right, time's up. We're going for a short break. Whoever who is here earlier, I intentionally display this step 2 over here, so you can read it again, and then you can feel that this time by reading this, your understanding is much more, at least twice, double from what you have read at 6:10. Now it's 6:45. It's about 30 minutes. So let's do a 5 minutes water and toilet break. Then we'll come back. Thank you. right? For whoever who is back, you can try to read this step 2 again. Right. Can I have a show of hand who, if you're back? All right. Okay. I think everyone is ready. So let's stop the timer over here. Now I think you have already followed this class for many sessions. Let me tell you a bit more about the class and the steps. By now, you should know we have these 10 steps and we have this 2 hours to follow these 10 steps. And by the end of the 2 hours, two of you, most of the time, you get 9 out of 10 or even 10 out of 10. The MCQ that is provided is not very difficult like your exam, your school exam or your public exam. But the MCQ that is provided is enough for you to know that you did not your 2 hours is well spent, because these 2 hours confirms that you are able to understand to a good level of the entire chapter, and it's only 2 hours, right? By following this 1 to 10. Moving to a next level, if you are ready for that, is to be able to create the notes for another chapter of yours. You can try with chemistry, you can try with biology, you can even try with history or computer science or geography, okay, whichever subject that you think makes sense. Create these notes. You can use, if you are familiar with AI, you can use AI to be able to create this for you, because AI is can work wonders, right? As long as you understand the concept. The concept you see is step 1 is to create the drawer, and that build this level 1 information or knowledge that you need to proceed to step 2 and so on. Then step 2, you have some key points with some very concise and short explanation, which most of the time you do not understand fully, which is fine. Then step 3, we expand it further. Then step 4, we turn it into another angle, which is question and answer. Then step 5, we move it back to giving you more informations. Some of the informations are repeated. In case you miss it in step 3, then this is where you're going to pick up. If you already read it and understood it in step 3 well, this is where you're going to do revisions, right? So different student will advance differently. So this is how this brain drawer is being created. So once this step 5 is done, then step 6. Step 6, we have another angle of helping you to understand this drawer 1 and drawer 5 better. Right, then you have step 7, watch the video. Step 7 is a quiz. Step 8 is watch the video, and step 9 is the podcast. Right. So this is how Brain Drawer is being designed to help you to have a good understanding of the entire chapter in just 2 hours, right? Okay, so let's come back to step 5 for our this chapter measurement. So let's do 1 minute from here to here, right? Or I'll do 2 minutes for the entire drawer 1. I'll slow down as we progress, right? Let's do it now. The intention is to level up from your understanding of level 4 to 5. All right, I'll scroll down a bit more. Okay. You should be in point 1.2 by now. One more minute. Twenty seconds. Ten seconds. All right, time's up. I hope it's not too fast or too short, the time that's given. If it is, just raise your hand, then we can adjust accordingly. All right, so your drawer 1, your understanding level should increase to 5 now. Now let's do drawer 2 with the same expectation. You need to have an expectation before you do something, right? So before you read drawer 2, step 5, your expectation is to increase from 4 to 5 understanding level. Let's do 2 minutes for the entire drawer. I'm going to scroll down a bit as we progress. It's base quantity, right? You are as the base drummer. One more minute, you should be in 2.2 at least, or 2.3. Thirty seconds. Ten seconds. Thumbs up. Right, let's proceed to drawer 3. Drawer 3, okay, it's about 1 page. Same thing. Let's do it now. Okay, I'll scroll down a bit. Okay. One more minute. By the way, you don't need to memorize this derived formula or derived quantities because there are millions of them. These are just examples. You just need to know the concept. What is derived quantities? It's from the base quantities. Okay, 10 more seconds. All right. Drawer 4. Drawer 4, let's do the same thing. Okay. 2 minutes. Start now. Thirty seconds. All right, time's up. Last drawer. Okay. Before we go to step 6, let's start now. Okay, I'll scroll down a bit. One more minute. You should be in 5.2 by now. 30 seconds. 10 seconds. All right, thumbs up. Okay, let's do a very quick recap. Now, your understanding level should be 5 now. 5 is out of 10 questions, you should be expecting yourself to get 5 out of 10. That's 5, right? If today, now, your science or physics teacher asks you, what have you learned in measurements? How would you answer him or her? Or your best friend asks you, can you teach me or can you tell me what is about measurement? Right. How do you explain to him or her? First, you try to recall the main story first. Right. The main story is you as a bass drummer and you met Scarlett and Victor, who is riding a giraffe. And that means that you have measurement, base quantity, derived quantity, scalar and vector quantities, and graph. Then from there, you can explain to them that what is measurement, right? Which is these 3 important keynotes or key point concepts. Then you have base quantity. What is base quantity, right? Although by now maybe you still cannot remember the 7 base quantity, but you can at least tell them that there are 7 base quantities, and they are quantities like the one that you can remember, which is length, which is time, I think. Right, those are common quantities. Then you can also tell them about the international system, the SI system, right? And quantity, base quantity cannot be derived. That's the basic. Next, derived quantity. The name itself gives you also an idea what is derived quantity already, following what you have learned just now as base quantity, right? Then drawer 4, scalar and vector quantities. The scalar is with magnitude, the vector is with magnitude and directions. So you can give some examples. Then how do you use what you have learned just now to interpret it into graph? Right, you have proportional, you have linear, you have gradients, you have area to talk about, right? So easily, you can talk about 10, 20 minutes if you break it down one by one and explain it slowly. Even at the level of 5, remember, we are still at the level of 5, right? So now let's move to another level. We want to improve your drawer 1, 2, 3, 4, 5 to 6, 60% by creating a short story for each of the drawer to help you to be able to remember the key concept in each of the drawer. All right. So you have this first drawer, the story. Magnet pulls you into matrix and become imperial emperor. Magnet pulls you into matrix and become imperial emperor. The story that I created doesn't make sense. It just need to be silly. Silly enough for you to be able to create some emotions, and that will help you in a long-term memory. If you remember, I have already told you this formula. Information plus emotion equivalent to long-term memory. So this is what I'm doing. Magnet is talking about magnitude. So you have something about magnitude in the measurement over here. Then unit is U. Matrix is this matrix, right? Imperial emperor, imperial systems, right? So you have matrix versus imperial. So you can talk about these key points by just remembering this very silly story, right? So you can see this picture that I've drawn is to illustrate that story. So let's go to drawer number 2, right? Base quantity. Little monkey take tea in lighted magic, right? So you can imagine there's a little monkey, like a baby monkey, but I call it little because L represents something, not B. The L in the little represents something. So you have 7, you still remember you have 7 base quantities. If you can remember this story, then you are able to remember the 7 base quantity easier. Little monkey take tea, that means he drinks tea, in lighted magic, right? So lang is the little, mass is monkey, take is time, T is temperature, in is current. Current usually is, the symbol is I. Okay, I use current, so it's a bit tricky over here. If you read, I think, yes, we went through the electricity, right? I still remember first drawer is the current. Current, the symbol, if you still remember, it is I. So that's why I put in I. Then light is lighted, right? It sounds even easier to remember this one. Then substance is magic, mold, right? You can change your own story if you like. If you don't like M, you like S, change it to something else, like the S submarine or whatever that makes sense to you or can create emotions, right? So next, drawer number 3, the story is base plus base because it's a derived quantity. So base plus base. Drawer number 4, scalar versus vector quantities. So scalar has magnet, vector has magnet and compass. What does it mean? Scalar is representing scalar, obviously, has magnet. Magnet is magnitude. So scalar quantity is only having magnitude. And vector is vector is having magnitude and direction. Compass is representing direction, right? I hope you know what is compass, right? If you don't, you need to find out. Graph, drawer number 5, graph. Popo and me walks in the same direction together into the universe, right? So you and your Popo walk in the same direction into this universe. Interpol joins to walk up the slope. Okay, Interpol is like a police, join to walk up the slope, right? Popo is talking about the proportional, right? There is this keyword that you always read in the previous steps is about proportional, right? So that is to represent the Popo. In the same direction, right? Proportional. So in the same directions. So your your axis y and axis x, if they are proportionally and the same direction, so they are going to increase together linearly, right? I think you also remember the words linearly. So in the same direction is to represent that proportional plus linear, right? Into the universe, right? Into the universe is to represent the in is inverse. So you have proportional, you have inversely proportional. Inversely proportional is the other way. When it increases, it doesn't increase together, it decreases. Right? Just like your gravitational force, the formula, remember, it is inversely proportional to the distance between the two planets. The gravitational force is inversely proportional to the distance of the two planets. So this in is to represent the inversely, right? So the graph can also have inverse relationship, not only the same direction relationship, right? Universe. Let me think. What was this keywords for the universe? For now I can't remember. Oh, okay. I think I know. Inverse, non-inversely. So the verse is universe. Sound like universe. So inverse into universe. So inverse. Right? I hope it makes sense. So it's to explain this. Right? Then interpole joins Papa and you and walk up the slope. Right? Interpole is to represent these interpolations. So there's also another skill that you can interpolate or extrapolate. Right? I think you already read what is interpolate and extrapolate just now. So this is to help you to remember there's this interpolation and extrapolation. Once you remember interpole, obviously, I hope you will relate it to extrapolation. Walks up the slope. Slope is gradient, right? Slope is gradient. Okay. So now let's watch the video quickly. Where was it? I think I opened it just now. All right, let's continue. Okay, since it's only 1 minute, I will just rewind, start from 0 and watch it now.
Form 4.
Yep.
Chapter 1. Measurements. Me, the bass drummer. Meet Scarlett and Victor riding giraffe. Draw 1. Measurement. Magnet, pull you into matrix. And become Imperial Emperor. Draw 2. Base quantities. Little monkey, take tea, enlightened magic. Enlightened magic. Draw 3. Derived quantities. Base plus base. Draw 4. Scalar versus vector quantities. Scarlett has magnet. Victor has magnet and compass. Draw 5. Graphs. Popo and me walks in the same direction together into the universe. Interpole joins 2 walks up a slope.
All right. So this is step 6. Easy, right? Step 6. Now your understanding level should increase a little bit more from 5 to 6. Now 7. 7 is quiz. 7 is quiz. So how do you do this? You read this and you ask yourself, which drawer is this? Before you read the answer, you form quickly your answers based on what you have learned from step 1 until step 6, including that story, okay? Including that story. Then you compare your answer against the answer is provided. If it is the same, excellent. If it is not, also excellent. This is new thing that you remember or you understand. And that will help you to increase from 6 to 7, right? So let's do 1 minute for question 1 and question 2. Let's start now. Let's do 1 minute. Question 1, question 2. Ten seconds. All right, let me stop here and explain a bit. So I hope that story just now in the step 6 a while ago is able to help you to remember to know what is the answer for these questions. Right? Remember that story for drawer 1. Let's go back. Magnet pull you into matrix and become Imperial Emperor. So magnet pulls you. So magnitude and unit. Right? That is mainly about question 1. Question 2 is about the matrix and imperial. Right? The matrix and imperial. right? Okay, so I hope your understanding now increased to 7 for drawer 1. So let's go to drawer 2. Let's do 1 minute as well. Let's do the same thing and start now. Ten seconds. All right. I hope that story of the little monkey is able to help you to not only provide 2 examples, you can provide 7 examples. Little monkey takes tea in lighted magic, right? Lighted magic. Now we have drawer 3 and drawer 4 for 1 question each. Let's start now. Okay, 30 more seconds. You should be in drawer question 6 now. Okay, done. Now let's move on to 7 and 8. Same drill for drawer 5. Oh, let's scroll down here. Okay, 7 and 8, 1 minute. Twenty seconds. All right, let's go for the last set of questions before we go for a video. Let's start now. 10 seconds. Right? We started at 6:10. Now it's 7:20. So it's slightly more than 1 hour. And we're almost done because today's chapter is relatively easy. So we are in step 8 now. We're going into step 8. I hope by now, if you read this step 2 here again, I hope by now you have much better understanding compared to 1 hour ago when you started reading this step 2. Right, when you started reading this step 2, your understanding level, if you quantify it into number, it should be at the number 2, the low number 2. Now, at this point of time, after slightly more than 1 hour, it should be at number 7 out of 10. Right. So let's try to increase it further to 8 by watching this video. Okay, let's wait for a while.
Hey everyone, welcome back to The Explainer. So glad you're
Okay,
here
just
today,
to make sure that
because we're
everyone
about to
can
do
hear
something
and
pretty incredible.
see.
We're going to decode the
Can I have
physical
a show of
universe.
hand? If you
Have you ever
can.
wondered how physicists actually describe reality? Well, it all
Okay, Aiden can see and hear. Okay, I hope Xingling is also able to do that. Xingling, can you? Can you hear? The lady was speaking. Yep, excellent. Okay, I'll repeat this. How do you watch this? It's going to divide it into the 5 drawer also, right? So intentionally relate what the lady is going to tell you just later to what you have learned just now. You can relate it with using the story of the drawer, or you can relate it using your notes that is right in front of you, or you can relate it using maybe the picture you have drawn by yourself, right? But the main objective here is to relate, right? Let's start now.
So glad you're here today, because we're about to do something pretty incredible. We're going to decode the physical universe. Have you ever wondered how physicists actually describe reality? Well, it all comes down to the fundamental building blocks of measurement. Today, we're unpacking the exact tools and concepts scientists use to translate our messy, beautiful real world into precise, universal numbers. To do that, we're going to open up a sort of 5-drawer toolbox. First, we'll look at the meaning of measurement, then check out the 7 base quantities, see how we build derived quantities, compare scalar versus vector quantities, and finally, master some key graph analysis skills. Let's get right into it. All right, drawer 1, the meaning of measurement. So let's frame this with something you probably use, every single day. How does your GPS know exactly where you are on the map? It's not magic, right? It's actually a physical mystery solved by incredibly precise measurements. It determines your location simply by measuring time and distance using satellites. And this brilliantly illustrates exactly why that accuracy matters so much. Whether NASA is calculating the exact trajectory to launch a rocket into space, or say we're tracking the recorded time of 11.87 seconds for a Paralympic sprint champion like Mohamed Rizwan Pouzi, measurement determines exact locations and outcomes. I mean, a tiny error, that means missing the moon entirely or missing out on a world record. There's literally no room for error. Now, a physical quantity breaks down into 2 non-negotiable halves. To accurately measure anything, you absolutely need a numerical magnitude, that's the how much, and a specific unit, the of what. Think about it. Saying a mountain is 4,095 means absolutely nothing. But saying it is 4,095 meters high, well, now you've given it physical meaning. But, simply having a unit isn't enough. We actually have to agree on which ones to use. We see this clash all the time between the globally familiar metric units like centimeters or kilopascals and imperial units like inches or PSI on your tire pressure gauge. For scientists to communicate accurately across the globe without, catastrophic misunderstandings, standardizing these units is absolutely vital. Actually, just ask NASA. They once lost a $125 million Mars orbiter simply because one team used metric and another used imperial. Crazy, right? Okay, moving on to drawer 2, the 7 base quantities. I want you to think of base quantities as the fundamental flour and eggs of physics. By definition, a base quantity is a physical quantity which cannot be derived from another physical quantity. They are the absolute bedrock. You literally cannot break them down into anything simpler. So the crucial point here is this definitive list established by the SI system. Out of the infinite complexity of the whole universe, there are only 7 fundamental quantities we need to measure everything. We've got length, mass, time, thermodynamic temperature, electric current, luminous intensity, and amount of substance. Master these 7 SI base units, and you essentially hold the keys to physics. Let's pop open Drawer 3, Building Derived Quantities. This is where things get really fun. If base quantities are the flour and eggs, derived quantities are the fully baked cake. They are formed entirely by describing physical quantities in terms of base quantities through simple multiplication or division. Let's visualize this. Imagine measuring the length of a box. Okay, that's one base quantity. Now multiply it by its width, which is just another length. Then multiplied by its height, a third length. By multiplying the base quantity of length 3 times, we magically derive the entirely new quantity of volume. In fact, almost every complex concept you hear about in physics works exactly this way. Take a look at density. It's really just mass divided by volume. Velocity, that's just length divided by time. Even force, which we measure in newtons, is simply a mathematical combination of kilograms, meters, and seconds squared. The whole shebang traces right back to those original 7 base units. All right, drawer 4, scalar versus vector quantities. Picture some students out on the field during a PE lesson. In one scenario, the teacher instructs them to run 50 meters, and they just scatter, right? Running a distance of 50 meters in any random direction. But in situation 2, they are running 50 meters straight toward a specific target, like a tree. This brilliantly illustrates the stark contrast between 2 distinct types of quantities. A scalar quantity, like that first group running a simple distance, well, it only cares about how much, the magnitude. But a vector quantity, like the second group running a specific displacement, demands to know how much and in which direction. So speed is a scalar while velocity is a vector. Make sense? And finally, drawer 5, mastering graph analysis skills. So we decode all these relationships we've been talking about through graphs. The simple shape of a graph instantly tells us the exact relationship between 2 physical quantities. A straight line through the origin screams directly proportional. A rising curve tells us y increases as x increases, while a falling curve tells us they have an inverse relationship. Basically, the shape is the story of the data. But just reading the shape is only step 1. To truly analyze an experiment, you need 4 essential skills. Calculating the gradient, or the slope, often reveals a hidden derived quantity like acceleration. Calculating the area under the graph might reveal distance. Along with interpolation and extrapolation, these skills are basically like reading the ultimate blueprint of a physics experiment, allowing us to form a solid conclusion and complete the experimental method. So we've built reality from the ground up using length, mass, and time as our foundation. But to truly test your understanding, I want to leave you with this provocative question straight from our source material. What constraints would physicists face if force, area, and time were chosen as the new fundamental base universe instead of mass and length? It's a massive shift in perspective that completely challenges everything we just learned. Think on that for a bit, and I'll catch you in the next explainer.
All right. Interesting. Now we are going to step 9. Step 9 is podcast. As usual, I'm going to play the podcast. It's only about 4 minutes, I think. Then I will
Imagine
highlight.
trying to build a modern city, or coordinate
Okay, it's about 5 minutes, 5 to 6 minutes. So I'll highlight the point that they are explaining. So this will keep your mind focused. Let's start now.
global air traffic without a universally agreed upon definition of an inch or a meter.
Oh, it would be pure, unadulterated chaos.
Right. Welcome to today's deep dive. We are unpacking the fundamental language of the universe today, which is, well, measurement.
Yeah, and our mission is to give you a shortcut to understanding this invisible scaffolding that lets us quantify reality.
Exactly. We're stripping away the static so you get straight to the core insights.
The irony is, we take measurement completely for granted in our daily lives. I mean, a measurement isn't just a number floating in the ether.
That needs context.
Exactly. It's a very specific pairing. You have a magnitude anchored to a unit, like if your car's dashboard says 100.
That implies wildly different realities depending on whether the unit is kilometers per hour or miles per hour.
Yes. And the stakes for getting that pairing wrong are surprisingly high.
Oh, totally. Just think about the GPS system on your phone. To pinpoint your exact location on Earth, it relies on, like, incredibly precise measurements of time and distance beamed from satellites.
And if those units are jumbled, the whole system collapses.
Which is why everyday tools, like a standard tire pressure gauge, still force us to navigate both metric kilopascals and imperial psi. We're constantly translating reality just to function.
Right, which is exactly why the scientific community had to force a consensus. In 1960, a global agreement in Paris established the International System of Units, the SI system.
Wait, hold on. 1960.
Yeah, 1960.
We were literally in the middle of the space race. We split the atom and built nuclear reactors before we had a globally finalized universal baseline for a simple meter.
I know, it sounds crazy.
How did international engineering projects not constantly crash and burn?
Well, they actually did struggle with localized discrepancies. That is what makes that 1960 agreement such a watershed moment. It wasn't just about convenience.
It was about standardizing the tools.
Exactly. It was about finally establishing the foundational alphabet of physics. They locked in 7 irreducible base quantities: length, mass, time, thermodynamic temperature, electric current, luminous intensity, and amount of substance.
Wow. Okay, so those 7 base quantities cannot be derived from anything else.
Nope. They are the absolute bedrock of physical reality.
Okay, so if those 7 base quantities are the core letters of our universal alphabet, then derived quantities are the words we spell with them.
That's a perfect way to look at it. We build complex concepts by multiplying or dividing those core letters, like volume is just length cubed.
Okay, let me push back a bit, or maybe just check my understanding. Are complex units of force, like a Newton, essentially just base units wearing a trench coat?
I love that. Yes, the trench coat analogy holds up perfectly here.
Underneath, a Newton is really just mass, length, and time structured together, right?
Precisely. A Newton is a derived quantity acting as a necessary shorthand. You are describing a dynamic physical interaction kilograms times meters per second squared, without having to spell out that entire mathematical phrase every single time.
Okay, that makes sense. But spelling out the amount of something only gets us halfway there.
Right.
The next major hurdle in quantifying reality is pinning down intent or movement in three-dimensional space.
Yes, the massive leap from scalar to vector quantities.
Right.
And it is a vital distinction. A scalar quantity only gives you magnitude, just the raw size or amount. But a vector locks in magnitude and couples it with a highly specific direction.
Let's ground this in reality for a second. Say you are driving to Kota-Kinabalu.
Okay, road trip.
You cover a total distance of 333 kilometers, cruising at a speed of 80 kilometers per hour. Those are purely scalars, right? Just raw amount.
Exactly, no direction attached.
But if you hit the gas to pass a truck, applying an acceleration of 1.2 meters per second squared toward your destination.
The moment that specific direction is introduced, you are operating with a vector.
Got it.
And to map out how all these scalars and vectors interact dynamically, scientists rely on graphs.
But graphing isn't just about, plotting data points for visual flair.
Oh, definitely not. It is about decoding the hidden rules governing those interactions. When we F shape.
Like distinguishing a straight linear progression from a curve passing through the origin.
Exactly. When we do that, we are literally watching physical laws manifest visually.
Which perfectly explains the scientific obsession with repetition and experimental methods.
Oh, absolutely.
Like, take the classic example of timing a simple pendulum. You don't just measure one swing, right? You time 20 continuous oscillations and average them out.
Yeah, you're not doing that just to find a single number.
You're actively smoothing out human error. So the resulting graph actually reflects pure mathematical reality.
And by calculating the gradient or the area under that graph, you uncover entirely new derived quantities. It is literally like discovering new vocabulary in that universal language.
It's amazing. So we have traced the evolution from those 7 foundational letters of the scientific alphabet, built them into complex derived words.
And used graphs to decode the grammar of the physical world.
Which leaves you with a pretty wild thought to chew on.
Oh.
Yeah, if absolutely everything we currently understand about the physical universe is constructed from just those 7 base quantities,
Right.
What happens to our entire grasp of reality if we suddenly discover a cosmic phenomenon that simply cannot be measured by any combination of them?
Oh, wow. That would break physics.
It really would.
Oh.
Keep questioning the scaffolding around you, and we will catch you on the next deep dive.
All right. So your understanding level should be around 9 by now. We will test it out to see if it is really what you feel that it is 9. Right? Let's do this exercise. Okay. Let me do the same thing. I'll put it side by side with these keynotes over here. Okay, are you ready? Okay, ask me 10 MCQ 2 by 2 without answer. If I got it wrong, then explain why. All right, let's start now. Question 1. Drawer 1, measurement. You can type in or you can tell me. Aiden, you can also type in or you can tell me if you want. Question 1, what is the answer? Question 2, what is the answer? C and B. Let's wait for Aiden. C and B. C and B. Okay. All of us, including me. Great. Let's go for the next set. Which one is base quantity? So you have to remember that little monkey story. Taking T. Number 3 is C. Number 4 is C and B. Aiden is A. Okay. I think it's B. Let's see A or B. Okay, you change to B, right? So we will not ask the AI to tell us to explain why it is wrong. All right. 5 and 6. Drawer 3, derived quantities. Okay. Remember the little monkey story can also help you to answer question 5. 5 is D. 6 is density. Okay, 5 is D. What about 6? Anyone want to try? Xingling, what about you? Give a wild guess if you do not know. Then we'll ask the AI to tell us the right answer. B. Okay, me too. Let's see. Right? Excellent. Density is mass divided by volume. Okay, next set, 7 and 8. Drawer 4, vector quantity. What is vector? Right, remember the story? Magnet and compass. C from Aiden. Scala and quantities. B. Aiden, do you agree it's B? Right? Remember the magnet and the compass. Okay, me too. I agree this is the answer. Let's go for the, yes, I saw you agree. Last one, drawer 5. Straight line graph that passes through the origin represents, okay, remember the purport. Okay, 9 is A from Aiden. Is it A? Ten. Singling, is it A for 9? And what about 10? Okay, we have two answers here. 10 is C. Okay, we have C also. So Aiden, do you think it's A or B for 9? What is the difference between inverse proportional and direct proportional? Inverse proportional means if there are two relationships, one you increase the value, and that other relationship, when it is increased, it will decrease. One very recent example, you remember the gravitations, the force, and the relationship with the distance. The force decrease when the distance increase. That is inverse. The force increase when the distance decrease. Okay? So that is inverse. So it's B. No problem. No need to be sorry. We are here to learn. Okay? Excellent. So it's about 9 to 10 out of 10. Okay? So this proved, or maybe between, I would say 8 to 10. Right? 8 to 10, which is also considered a very good achievement, because in less than 2 hours, is even less, it's about 1.5 hours, you are able to have a good understanding about this chapter. 1.5 hours, right? Only 1.5 hours, you are able to have a good understanding from 1 to 9, level 9 or level 8, if you want to be more humble, right? So how do you maintain at level 9 or level 8 consistently? Then this is the revision method, right? Which we explained when we started the class on the previous chapter on gravitations. The same method can apply here in this chapter, right? So thank you very much. I think we are done for this week. So let's continue on the next week if you are available, right? Thank you. Bye-bye. Bye-bye. Hope you learned something new today. Bye-bye. See you next week.